A laser cutter is a high-tech machine that factories use to cut parts out of metal. The traditional way to cut metal is with a stamping press, a slower process that requires a separate tool for each type of cut. A laser cutter's computer-guided beam can precision cut virtually any shape. A laser cutter is made up of a laser resonator, which produces the beam, and a mechanical system that moves the laser over the metal in a computer-controlled pattern. To build the laser resonator, they mill 2 blocks of aluminum. Each will hold a mirror on opposite ends of the resonator. They will reflect light back and forth inside the chamber to form the laser beam. All the parts go into a cleaning solution because any contaminants would shorten the laser's life. Assembly takes place in a clean room. After mounting the aluminum blocks onto separate aluminum tubes, they slide one tube inside the other. This forms the resonator's main structure. They install an electrical connector on one of the blocks. Then they mount a mirror onto each aluminum block. A generator pumps electrical energy into a pressurized mixture of gases, producing particles of light called photons. The mirrors at both ends of the resonator direct the photons back and forth, creating the laser beam. They now fill the resonator with that pressurized gas. It's a mixture of nitrogen, carbon dioxide, and helium. For the laser beam to cut well, it has to be the right shape, but the beam is invisible. So to see its shape, they have to shoot it into a plastic cube and observe the formation it makes. They gradually fine-tune the beam's shape by adjusting the mirrors on the resonator. They keep at it until the laser cuts a cone formation in the plastic. On top of the tubes, they install a square housing containing a series of mirrors which further refine the beam. Meanwhile, a robotic welder fuses sheets of steel to construct the laser resonator's housing. On the main machine, these large suction cups move the sheet of metal to the cutting area. The sheet remains stationary, while a motion unit moves the laser beam over it. A rack and pinion system propels the motion unit. The system's racks must be perfectly aligned for the machine to cut accurately, so a technician uses precision measuring equipment to check the racks, then various tools to make adjustments. Once that's done, they set up the guide rails on which the motion unit rides, then mount the motion unit onto them. They bolt the motion unit to the front of the machine, and the housing that contains the laser resonator to the back of the machine. The resonator creates the laser beam. Mirrors deliver it to the motion unit's cutting head. Lenses inside the head focus the beam on the metal it's underneath. They run a series of tests to ensure the machine cuts with ultimate precision. It all boils down to whether the motion unit moves accurately, which means the drive system racks must be perfectly aligned. After testing, they enclose the cutting head with a safety cover made of sheet metal and plexiglass. The cutting head's copper-tipped nozzle emits the laser beam, while a curtain of brass pins confines that beam to a restricted area. The motion unit moves in 3 axes, enabling the laser beam to cut different thicknesses in 2 dimensions. A stamping machine leaves rough edges that workers must grind smooth afterward. But a laser cutter leaves a smooth edge that needs no further work. This saves on time and labor cost. making this technology a cut above.